Hi, my name's Alex. I'm going to show you how to handle ProtoSat and how to box it up, transport it. I'm going to show you how to unbox it and connect EGSC to it and get it to the point where you can talk to it and run tests and do demos and whatnot with it. A couple of things to point out. I'm wearing nitrile gloves so I don't get oils on any of the surfaces, and I'm grounded. That is the absolute bare minimum for handling ProtoSat. Under no circumstances should you ever touch ProtoSat if you're not grounded and you don't have gloves on. And I would also say wear a face mask so when you're talking, you don't get spit. Under some situations, you can get away with handling ProtoSat not in a clean room because there are no extremely sensitive optics on here. There is a payload module. The payload module is not a flight payload module. So if it gets dust into it, it's not the end of the world. It should be avoided. So try and not handle it outside of a clean room. Perfect example is during payload calibration, it was not a clean room and it was fine. Handling in a clean room is ideal and that's the preferred situation. It's way easier to keep ProtoSat clean than it is to try and clean ProtoSat when it's dirty. The next thing you need to know about handling ProtoSat is where can you grab ProtoSat. It's relatively small. It only weighs about 2.4 kilograms, so it's pretty light, but you can only touch ProtoSat on the rails. The rails are these guys here. They're anodized aluminum. This is the only area on the entire satellite that you can actually make contact with the satellite for lifting. You cannot touch the solar panels, and when you're touching the rails, be extremely careful of the deployment switches. These little levers here, while you can touch them, you do not want to touch them while grabbing and lifting because they're extremely fragile and the levers can easily break. So grab the rails, and only the rails with two hands. So you're making 4 points of contact like this. And before you do any lifting, get up and visually confirm that you're actually grabbing the rails and you're not grabbing the solar panels. If you grab and pinch and lift ORCASat via the solar panels, you will break them. These are extremely fragile and they cannot handle any sort of pressure on them. So get your thumbs on first, wrap around your hands like so. Visually confirm all of your fingers are making contact with just the rails. And then you can pinch, grip with your hand, and then you can lift it. Never lift it very high. Lift it only a few inches off the desk, just what you need. Just work with it on a desk. If you need to carry it from one room to another, put it in a box and wheel it over there. Keep it over a workbench, only grab by the rails, and when you do lift it and move it, you're just doing simple motions. The next thing I'm going to show you are these 3D printed transporters, I call them. They basically just make contact with the rails and they slide over the tops and the ends of the satellite, and it allows for, once you have two of them on, we put these threaded rods in and it allows for the satellite to then be resting on any face. You can't rest the satellite anywhere but the rails. The only time the satellite's actually resting on the rails is when it's resting on the wake or the ram face. Because you have these rail ends here that are further up above than the solar panels are, you can rest the satellite on the wake or ram faces. Just as an example, so you can see the bottom here. It's not resting on the solar panel, it's resting on the bottom of the rail ends here. So you can only rest it upwards or upside down. If you want to rest it, say on the zenith face, so you can access the nadir panel easier, you have to use the holders. And that's part of the packaging for transport. So we'll start with that. The very first step is to apply Captain tape to the lever switches. The levers are taped down flush to the rails, and there's no way that they can be caught and damaged when you are sliding on the holder. If they get caught on something and they get bent backwards, they will break very easily. You won't even notice that you're breaking them. So let's not do that. So we've got 1/4 inch Captain tape here, and all we're gonna do is just apply this over the lever switches, take my finger and just run it down and press it in, and then tape the other side down, and then any excess you can kind of just tape on the top. And that's all you're doing. One piece of tape is enough, and now the levers are sitting flush. I can rub my finger up and down on the rail and I'm not catching the levers. Now we have all 4 pairs of lever switches. They're taped up. So that's what the rails look like with the tape on them. So we have our rails taped up. we're gonna go ahead and put it in the holder now. So I'm gonna lift it on and put it in the holder. I'm then gonna take the top and slide the top on. Then I'm gonna rotate it and let it rest on its nadir face or zenith face, doesn't really matter. You can't rest it on port or starboard because the antennas are deployed. We're gonna get it resting on this face, and you just wanna grab the holders and just pinch them together and then lift. And it's good to get your fingers wrapped around it like this. So you're pressing them together and lifting the satellite. And when it's like this, it's relatively secure, and it's a good way to handle the satellite because the holder makes contact with the rails and you can just grab the holder. So this is 1/4 inch threaded rod from Home Depot. You want to put a 1/4 inch nut and a 1/4 inch washer, and you're going to feed this through the holders, making sure it doesn't make contact with the rails or the satellite all the way through. You then want to take a washer and put it on. Hold the rod in place, thread the nut on. Then you want to take 7/16 socket and just finger tight. That's all you need. You don't need much, just enough to make sure that the nuts don't come loose. Okay, we have the transporter on the satellite, and now it's way easier to move. You can grab it here, you can grab it here, you can pinch and grab it. Anywhere on the white 3D printed material you can grab, and you can get a much better grip, and it's much easier to lift and carry the satellite. You don't have to worry about just pinching the rails with your hands. You can just grab it and lift it. Very easy, very simple. So if you're only transporting at a short distance, you can just put this in the box that Protosat normally is in, and then just move the box around. If you just need to move it between rooms or put it on a cart and wheel it outside to do like GPS antenna tests or something like that, that's perfectly fine. If you need to transport it longer distances, such as with a vehicle or on an airplane, you should really put it into a much better and secure Pelican case with foam inside. We need to get these antennas stowed, so we're gonna do that by grabbing the satellite and flipping it up onto its ram face so I can get access to the antennas here. We're just gonna coil these up by hand, shove them inside the satellite, and then tape the door shut. So we're gonna grab the antenna and just coil it up. It's very difficult to stow it this way, but it's less difficult than taking the RAM panel off. I can see you've got it mostly coiled. Okay, so now it's all the way in there. So I can almost fully close the door. You just want to take some tape. It's kind of tricky to do this one-handed, so the first piece is just to get it on there. Second piece you can do a little better job. There we go. It's important to not get any tape on the solar cell or to touch the solar cell while you're doing this. Okay, now we're going to put it into a large ESD bag. This is a static shielded bag, so if you're statically charged and you touch the bag, you won't arc through to ORCASat. So all you want to do is just open the bag up, and slide it over the satellite. You want to make sure it's wide enough that it's not touching the solar panels too much. Once you get it down like this, you kind of just want to like fold it over and grab the holder through the bag, rotate it around, and then just kind of tilt it up. Like this. And then you're just looking to grab the bag and slowly lift the bag up. Let the satellite kind of fall to the bottom. Once the satellite has fallen to the bottom, you're pretty much done. Once again, when you're handling with the bag, you just want to be careful not to damage the satellite by like pressing through the bag. So we can do the top up. And we just want to fold these in using some more Captain tape. You can just secure those in spot. And if you notice that when you fold it over, you get a little bit of bulge of air in there, it might be a good idea to just try and get a little bit of the air out without touching the solar panels too much. ProtoSat boxed up, or bagged up I should say. It's ready to go in its box. This is a Pelican case. It's a IM2450. It's small enough to take as a carry-on piece of luggage on the airplane, so you won't get any issues if you need to fly with ProtoSat. There's two cutouts in here, one for FlightSat, one for ProtoSat. FlightSat's gone to space, so you know, you won't be able to put it in here. I like to put ProtoSat in the middle one, just so it's got the most amount of padding around it since there's no satellites in here. Place it in, and the foam's a nice tight fit, so you can just drop it and let it slide in. Perfect. You can put whatever tools you need in the slot. I like to put things like the EGSC cables. I like to put the sockets for taking the transporter bolts out in here as well. And then you can just close the lid, lock it up, and you're ready to transport it. So for unboxing the satellite, it's exactly the same steps as boxing it, just in reverse. So you want to take the satellite out of the box, you want to take it out of the bag, you want to undo the tape and let the antenna shoot out, and then take the transporter off. If you don't need to do all of that, like if you're not taking photos of it, I recommend just leaving it with the antenna stowed inside and the transporter on it. Makes it way easier. I will give you a good tip though. For taking the satellite out of the box, it's way easier just to lift the foam out like this. And then you can just grab the satellite like that and lift it out. And it's much easier than having to try and jam your fingers in the foam and lift the satellite out. And the foam will stick to the satellite too, so it's just not a good idea. Okay, so I've unboxed the satellite and I've put it in its protective case. Keeping it in this box allows people to be a little bit more free and a little less careful, because if they do, say, drop something, it's going to hit the lid of the box and not the satellite. I also didn't mention it earlier in the video, but if you noticed, I tried to work around the satellite and not over top. And that was so if I accidentally dropped a nut or a washer or a screwdriver on top of the satellite, that'd be really bad. But if I work around the satellite and move the nuts and the washers around the satellite instead of over top, if I drop them, they'll just drop to the side of the satellite. So that's a good tip to keep in mind. There's 5 jumpers on the EPS that you can install to change the configuration of the EPS. There's some documentation online that'll give you a better idea of what jumpers do what and why you might want to use them, but I'll give you a quick overview. So from left to right, or forwards to backwards, we have the off EPS jumper. This is the kill switch. If this jumper is installed, which it currently is, the satellite will never turn on under any circumstances. Next to that, we have the off dist jumper, which stands for off distribution. That allows the EPS to turn on and you can charge the batteries, but none of the loads will turn on. So the OBC won't turn on or anything like that. Then we have the micro USB connector. That's so you can plug a USB cable in and use the EPS ground support software. Next to that, we have the on EPS jumper. That forces the EPS to turn on, and that's very useful when we're in this configuration where the deployment switches were taped down. If you just pull the off EPS jumper and you apply power to the satellite or sunlight, it won't turn on because the deployment switches are pressed down. They're actuated. So you have to release them, or you can install the on EPS jumper and that forces the satellite on. Next to that, we have this jumper which is installed, which is the fast on jumper. That bypasses the 35-minute deployment timer and it turns on basically instantly, like half a second or something like that, which is a good idea when you're just handling it on the ground. So you don't have to wait 35 minutes for the satellite to turn on. Next to that, we have the off heart jumper, which disables the heartbeat functionality. The heartbeat functionality is a feature on the EPS where it requires a 1 pulse per second heartbeat signal from the onboard computer once the EPS has turned the onboard computer on. If it fails to receive that 1 pulse per second, it resets the entire power system and satellite for 11 seconds and then turns the OBC back on. It's like a master reset feature, but it can be very annoying to have that feature when you don't have an OBC installed. So that jumper allows you to use the EPS and test the EPS without an OBC or without a signal generator providing the 1 PPS signal. Because we have an OBC, this is in the final integrated version of the satellite, we don't need that jumper installed. And then the furthest jumper is the on TLM jumper, which stands for on telemetry. It forces the telemetry collection system of the EPS to turn on without using the onboard computer. So a situation you may want to use that when you don't have an onboard computer to turn the EPS telemetry on. But the 2 most used jumpers are the off EPS, the on EPS, and then the fast on. In this case, what we're going to do is we're going to move the off EPS jumper to the on EPS position. So this is going to force ProtoSat to turn on. Now, ProtoSat won't turn on because there's no power. Once you've installed the on EPS jumper, you still need power to start the turn on sequence for ORCASat. And you can get that power by either shining a bright light on the solar panels or by connecting the power supply cable. You can plug this in. We can plug this in and it latches in there, and now we have the power supply cable plugged in. As soon as we turn the power supply on, ProtoSat will turn on now because we have the on EPS jumper installed and the fast on jumper installed, and there's no off EPS jumper anymore. We'd like to be able to talk to satellite, and so we need to install the EGSC for the onboard computer, so we can actually talk to the onboard computer via the ground control software Houston. That's this port here. That's the OBC electrical ground support equipment port. So I've just gone ahead and plugged it in. So now we've got the EGSC dangling off it, and that just requires a micro USB cable connected in. And that's it. Some other features I'll point out. This port up here is the payload serial port. It's also a USB connector. If the payload is turned on, you can plug a USB cable in there and talk to the payload directly without using the onboard computer. And then down here we have the TT&C EGSC. So we've got a serial port to talk directly to the radio, and we've got some configuration headers to talk directly to the radio. The next thing we have to do before we go ahead and turn the satellite on is install the antenna disarm jumper. That's this jumper right here. So because I have the antennas stowed inside the satellite, the antenna deployment switches are actuated, and so the satellite thinks the antennas are stowed, which they are. One of the very first things it does when it turns on is try and deploy the antennas. This antenna disarm jumper just tells the onboard computer that, hey, the antennas are deployed. You don't have to try and burn the wire and deploy the antenna. So it skips that step. Normally you don't need this jumper if ProtoSat has its antennas deployed. For our power supply, you want to make sure it's set to 5.3 volts at around 1.9 amps. If you don't know what the state of the charge of the battery is, just set it to 1 amp. 5.3 volts at 1 amp is going to be fine, and you're not going to damage anything with that. I know the battery is not deeply discharged, so I'm just upping the current a little bit. Once you turn the satellite on, it should be reading 5.3 volts output, and you should have anywhere between a couple hundred milliamps, like in this case we're reading 280 milliamps, up to the full 1.9 amps, and it'll be current limiting. Okay, so I can go ahead and turn the power supply on. You'll see there's a small red LED right there that turns on when the power supply turns on. That's the EPS distribution error LED. That is just telling you that, hey, the EPS has power, but the outputs aren't on because the reset timer is preventing the outputs from turning on. Once the 11-second reset timer expires, it'll turn the outputs on, and as long as it has that 1 PPS, 1 pulse per second heartbeat signal from the onboard computer, it'll stay on. And as you can see, after about 10 seconds, the light has turned off, and that means that the onboard computer has turned on and it's keeping the power system on. Another good way of checking that is looking at the EGSC. And if you see a blinking light for the heartbeat, that means that it's on. And the heartbeat is this guy right here, as well as more LEDs will turn on. As soon as you plug the USB cable into the computer, one LED will turn on, but the other two don't turn on until the OBC is actually on, and then the heartbeat signal is blinking, just letting you know the OBC is actually on and doing things. So we've unboxed ProtoSat, we've put it in the box, we've configured the jumpers, forcing ProtoSat to turn on via the on EPS jumper. We've made sure that it doesn't wait the full 35 minutes to turn on, so we've installed the fast on jumper. And because the antenna is stowed inside the satellite, we've installed the antenna disarm jumper, so it doesn't try and deploy the antenna and wait to do that during the boot sequence. We've also connected the power supply cable so we can give it power and charge the battery. And we've connected the OBC electrical ground support equipment so we can use our ground control software Houston to talk to the onboard computer and actually do things with it.